Welcome to TDS Online Math. Alright, so let's look at this proof. If 2 tan A is equal to 3 tan B, prove that tan A minus B, which is an identity, is the same as a fraction with the numerator sine 2B on 5 minus cos 2B. Alright. Okay, so let's see what we can do here. So we know 2 tan A is the same as 3 tan B, so we can rewrite 2 tan A equal to 3 tan B as we can divide both sides by 2. So we have tan A equals to 3 on 2 tan B, or you can say 3 tan B on 2. Okay, now let's focus on tan A minus B. We know tan A minus B is an identity. So it's part of the compound angles. And I'll put the link of compound angles under this video so that you can understand. So given tan A minus B is the same as tan A minus tan B on 1 plus tan A tan B. Okay, but what is tan A? Tan A is 3 on 2 tan B, so we can do substitution here. So in order not to waste time, let's focus on the right hand side. Okay, let's focus on this. So my next step, I will be on the left hand side, which is this. So tan A, so this is tan A. We can put 3 on 2 tan B, or the same as 3 tan B on 2 minus tan B, okay, on 1 plus. So we have 3 tan B. We have another one here, so we can still substitute tan B on 2. Okay, so let's find the LCM of both numerator and denominator here. Okay, all right, so with the numerator, the LCM is 2. 2 into itself is 1, so we have 3 tan B. Okay, 1 into 2 is 2, so 2B minus 2 tan B on, so we can make this side over 1, so we have 2. 1 into 2 is 2, so 2 times 1 is 2, plus, so 2 into 2 is 1, so we have 3 tan B tan B. Okay, so this is division, so this one will cancel this. Okay, so I don't want to waste time here. This one will cancel this. I want to divide this one by that. This one will take the reciprocal, which the 2 will cancel itself. Okay, so my next step will be tan B on the numerator. So that's that. We have 2 plus, so tan B can be tan squared B, so we have tan squared B. Okay, it's double. All right, so we have this, but let's put our attention on the sine 2b on 5 minus cos 2b. Okay, definitely we are going to apply double angles theorem or identity here. Okay, so we know tan b from our basic trick. Tan is the same as sine over cos. So tan b can be written as sine b over cos b. Since we have in terms of sine and cos, we have no option but to change this tan to sine and cos. So tan b on the numerator is the same as sine b over cos b. And we have 2 plus. So this side is tan squared b. So I will be getting sine squared b on cos squared b. Okay, so we have this. Okay, so we can simplify the denominator here. Okay, so we have sine b over cos b divided by, so let's simplify this and put the result here. So we have 2 plus 3 sine squared b over cos squared b. So I can make this side 1. Let's find the LCM. The LCM is cos squared b. So 1 into cos squared b is cos squared b. So it will multiply 2 here, b. So we have plus cos squared b into itself is 1. So we have 3 sine squared b. So we have this. Okay. So with the division, this one we will reciprocate. Okay. So we will turn this one. So I'll change this. Then this one also change. So cos squared b over 2 cos squared b plus 3 sine squared b. Okay. All right. So let's do our cancellation. So this cos b will remove one of this. Okay. So the numerator will be sine b cos b on 2 cos squared b plus 3 sine squared b. Okay. Now let's focus on the right hand side. We have sine 2b, and sine 2b is a double angle, and we need to adjust the numerator to look like this double angle, that is sine 2b. We know sine b plus b the same as sine b cos b plus cos b sine b. Okay. All right. So this side will be sine 2b. Okay. It's the same as, so sine cos. So this one multiplication commutative, the same as sine cos. Okay. So this side will be 2 sine b cos b. So let's observe this. So this side is sine b cos b. So we need to multiply this side by 2 in order to get this sine 2b. So we will adjust this by multiplying both numerator and denominator by 2 in order to get sine 2b here. All right. So the next step will be 2 sine b cos b on So 2 times 2 is 4 cos squared b. 2 3 6 sine squared b. Okay, so the numerator is simply sine 2b. So let's look at the denominator. We have 5 here, so we can write this one as, so let me write the numerator first. We have sine 2b. So this side can be written as 5 minus 1, which is 4. So 5 cos squared b minus cos squared b. Then this one is 6, the same as 5 sine squared b plus sine squared b. Okay, so let's arrange this. We have 5 cos squared b, then 5 sine squared b. So we have sine 2b on 5 cos squared b plus 5 sine squared b. So we have minus, so let me into this bracket, cos squared b minus sine squared b. Okay, now when you go back, you get the same thing. Remember, we can take 5 out, so we have sine 2b on, so 5 out, I'll get cos squared b plus sine squared b minus, so this one is also part of double angles, so this side is cos 2b, and cos squared b plus sine squared b is simply 1. So I'll put 1 here. So 1 times 5 is simply 5. So we have 5 minus, let me write it well, 5 minus cos 2b. All right, so this is the proof. All right, so thanks for watching, and don't forget to subscribe for more exciting videos. All right.